So moving on to page 5 of your notes there, it talks about excluding values from the domain of f composed of g of x. So it says the following values must be excluded from the input x. If x is not in the domain of g, it must not be in the domain of the composition. Any x for which g of x is not in the domain of f must not be in the domain of the composition either. So what that's telling us is just like the 1 and 2 that I talked about in the other video, okay? So what you're going to do is you're going to find the domain of the input. Which is what you're putting in, so that will always be your g of x. And then you're going to find the domain of the output. Which the output is our answer, so that's going to be that composition, okay? Alright, so you're going to find the domain of them. We're going to put it together, and then we're going to find the domain of the entire composition that way. Alright, and I'll show you when we actually do one. So let's go on and let's look at example 4. It says, given that f of x is equal to 4 over x plus 2 and g of x is equal to 1 over x, find f composed of g of x. Alright, so example 4. So it told us that f of x was 4 over x plus 2 and that g of x is 1 over x. And it wants us to find f composed of g of x. Alright, so remember, we're looking for f of, well, we know what g of x is. That's 1 over x. So when we do this, then we're going to take that 1 over x and we're going to plug it into our f function. So that outside function is always going to be your skeleton. So 4 over, we have x plus 2. And what are we going to plug in? That's that 1 over x. Now you've got to simplify this part first. And so it has something we don't like. It has a fraction within a fraction. So this 1 over x right there, if it wasn't there, we wouldn't have an issue with it. So how do I get rid of the fraction? Like we've been doing before, you multiply it by x. But remember, what you do to one thing, you have to do to all. So all the different terms get multiplied by x. So we're going to simplify that. So we have 4x on top over this x and that x will cancel, so we got 1, and then 2 times x is a 2x. Alright, so there is our function simplified. Now, it asks us about the domain. So if you flip over your page onto the very back side there, there's a slide there to help you find the domain. Alright, so once you do that, let me erase this part. The first thing I would do is I would go ahead and write on that slide what our composition was. So, because it gives you f of x and it gives you g of x. So go ahead and write on there that f composed of g of x is that 4x over 1 plus 2x that we just had on the previous slide. So now that we're looking for the domain, remember you're going to find the domain of the input first. This is at step 1. Well, what was our input? We said it's going to be our g of x. And remember, g of x, it says up there, is 1 over x. So how do we find the domain of that? Well, it's a fraction. And we know if it's a fraction, remember that that denominator cannot equal 0. So set the denominator not equal to 0 and solve it. It's already done on this one. So we know x can't be 0. Not our final answer, so I circled it though because it is part of our final answer. And then step 2 was the domain of the output. Output was our final answer. So that was that f of g of x, which we said was 4x over 1 plus 2x. Well, again, it's a fraction, so we know that the denominator cannot equal 0. So 1 plus 2x cannot equal 0. Let's solve for x. So subtract the 1. So 2x cannot equal negative 1. Divide by 2. And we get x cannot equal negative 1/2. So both of these are part of the restriction. So I'm going to draw myself a number line here. I'm going to put my infinities. And I'm going to put those two restrictions. So we said it's going to be what, negative 1/2. Remember, that's to be a numerical order. Was our smaller one. And 0. And we said x cannot be them, so therefore we're going to put open circles. And just like we did before in the domain, if x can't be those two numbers, that means x can be all the other numbers. So shade everything else. So now we can see our domain. We can see that it goes from negative infinity to negative 1/2, and use a parenthesis because it's a closed circle. Union, negative 1/2 with a parenthesis to 0. Use a parenthesis because again it's an open circle. Union, and then the last part there is 0 with the parenthesis to positive infinity. And so this right here is the domain of the composition function.